Hi, I'm Mr. Michael of the Classical Liberal Arts Academy, and in this video we're going to get started with the first lesson in Ray's Higher Arithmetic, what we call Modern Arithmetic 4 in the Classical Liberal Arts Academy. As with most of our courses, in the beginning we take some time to make sure that we define terms. We establish the meaning of words that we're going to use to avoid confusion in our studies. It's important for students to understand that when we learn these definitions tell us how these words are going to be used in this textbook. So it's very important. You shouldn't use definitions of these words that you learn in other textbooks or that you hear in other places. When you see these words, these important words that we're going to study in this first lesson in this textbook, you should always think back to these first lessons when those terms were defined. So what I'd like to do, since this is a simple lesson, you really only have to learn these definitions. I'd like to walk through the definitions with you, make sure that everything is clear, and then leave you to study and memorize them and prepare for your lesson test. So let's get started and take a look at our lesson. Here on the screen we see article number 1, and we have the definition of a definition, as strange as that may be. But we learn what a definition really is. We read, a definition is a concise description of any object of thought. A definition is a concise description of any object of thought and must be of such a nature as to distinguish the object described from all other objects. A definition is a concise description. And notice there, we learn that a definition is a kind of description. A description may be true of more than one thing. I could say an apple is a red fruit. That would be a description because I can find other examples of red fruit, like a cherry. So a description and a definition are two different things. A definition is one kind of description. A definition is a concise description, and what makes it a definition is that it distinguishes the object from all other objects. That's a definition. That's the first term we learn in article number 1. Let's look down to article number 2. A quantity is anything which can be increased or diminished. Quantity is anything which can be increased or diminished. And you're going to see that this is important later on. Look down into Article 6 here. We see that mathematics is the science of quantity. Mathematics is the science of quantity. That word quantity is defined in Article 2. Quantity is anything which can be increased or diminished. Mathematics is the science of anything which can be increased or diminished. Anything that can become more or fewer, anything that can become greater or less is a quantity. Quantity is anything which can be increased or diminished. It embraces number and magnitude, and we'll see what these are further down. It embraces both number and magnitude. So number and magnitude are the divisions of quantity, two different kinds of quantity. Number answers the question, how many? Magnitude answers the question, how much or how great? Number answers the question, how many? And magnitude answers the question, how much. You should memorize this definition of quantity. Article number 3. Science is knowledge properly classified. Science is knowledge properly classified. And again, if we look down to rule number 6, we see mathematics is the science of quantity. Science is knowledge properly classified. So mathematics is classified knowledge of quantity. And by classified knowledge, we mean organized knowledge. Knowledge that's not just random, not just a bunch of facts gathered together in our mind, but a knowledge of a complete body of knowledge that's organized, systematized in our minds. That's what a science is. Science is knowledge properly classified. The primary truths of a science are called principles. This is Article 4. The primary truths of a science are called principles. The word principle means a starting point or a beginning. The primary truths, the truths that we start with in any science, are called the principles of that science. Article 5. Art is the practical application of a principle or the principles of science. And you should realize that science and art go together. Science is the knowledge of a subject properly classified. Art is the application of that science. Science is the classified knowledge. Art is the practical application or use of that science or knowledge. Article number 6. Mathematics is the science of quantity. Mathematics is the science of quantity. Mathematics is the main subject that we're going to study. This course, however, is titled Arithmetic, and arithmetic is one part of mathematics. Arithmetic is one part of mathematics, and we see that in Article 7 here. The elementary branches of mathematics are arithmetic, algebra, and geometry. The elementary branches of mathematics are arithmetic, algebra, and geometry. Article 8, we learn what arithmetic is, which is the subject of this course. Arithmetic is the introductory branch of the science of numbers. Notice that arithmetic doesn't deal with magnitude, it deals with number. Arithmetic is the introductory branch of the science of numbers. Arithmetic, as a science, is composed of definitions, principles, and processes of calculation. As a science, as a classification of knowledge, arithmetic is composed of definitions, principles, and processes of calculation. What terms mean, what the primary truths are, and how to perform calculations. As an art, arithmetic teaches how to apply numbers to theoretical and practical purposes. As an art, arithmetic teaches how to apply numbers to theoretical and practical purposes. Article 9. A proposition is the statement of a principle. A proposition is the statement of a principle. or of something proposed to be done. And remember, a principle was defined above as a primary truth of a science. A proposition is the statement of a principle or of something proposed to be done. Article 10. Propositions can be divided into two kinds. Propositions are of two kinds: demonstrable propositions and indemonstrable propositions. Demonstrable propositions and indemonstrable propositions. And here we learn what they are. Demonstrable propositions can be proved. That's what this word demonstrable means. Demonstrable means able to be demonstrated. Demonstrable. Demonstrable propositions can be proved by the aid of reason. Demonstrable propositions can be proved by the aid of reason. The other kind of proposition are indemonstrable propositions. Indemonstrable, and that means not demonstrable. Indemonstrable propositions cannot be made simpler by any attempt at proof. And it's simple enough to know that indemonstrable propositions are propositions that cannot be proven. They cannot be demonstrated. So two kinds of propositions: demonstrable and indemonstrable. Article 11. An axiom is a self-evident truth. An axiom is a self-evident truth. Self-evident means that there's no way to prove it. It doesn't need to be proven because it's self-evident. It's obvious to everyone. That's what self-evident means. An axiom is a self-evident truth. An example of an axiom would be, a part is less than the whole. A part is less than the whole. That's an example of a self-evident truth. An axiom is a self-evident truth. Article number 12. A theorem is a truth to be proved. A theorem is a truth to be proved. So a theorem, we assume, can be proved. An axiom, because it's obvious, cannot be proved. So an axiom is an example of an indemonstrable proposition, and a theorem is an example of a demonstrable proposition. Article 13. A problem is a question proposed for solution. A problem is a question proposed for solution. And then in Article 14, we're told axioms, theorems, and problems are propositions. Axioms, theorems, and problems are three kinds of propositions. Article 15. A process of reasoning proving the truth of a proposition is called a demonstration. A process of reasoning proving the truth of a proposition is called a demonstration. And again, that word demonstration, which simply means proof, we saw above in the word demonstrable. Demonstrable, able to be demonstrated. The process of reasoning that proves the truth of a proposition is called a demonstration. Article 16, a solution of a problem. Remember, problem is defined in Article 13. A solution of a problem is an expressed statement showing how the result is obtained. A solution shows how the result of a problem is obtained. Article 17. The term operation, as used in this book, is applied to illustrations of solutions. The term operation refers to illustrations of solutions. Article 18. A rule is a general direction for solving all problems of a particular kind. A rule is a general direction for solving all problems of a particular kind. It's a general direction because it applies to all problems of a particular kind. And Article 19, the last article we'll study in this lesson. A formula is the expression of a general rule or principle in algebraic language, that is, by symbols. A formula is the expression of a general rule or principle in algebraic language, that is, by symbols. So note the difference between a rule and a formula. A rule is a general direction for solving all problems of a particular kind. A formula is the expression of a rule in algebraic language, that is, by symbols. So that's all of the content for this first lesson in higher arithmetic, these first 19 articles. I hope that walkthrough is helpful to help you see the content and understand what's taught in this lesson. It's important for you now to go and study and memorize these definitions. These are the primary truths. These are the principles of arithmetic, these definitions. They're to be learned because they're the primary truths that we're going to use to build the entire body of knowledge that we gain about arithmetic, which is called science. So study these 19 articles, memorize the definitions, and prove your mastery on your lesson test. If you need any help, please contact me. God bless your studies.